Organic chemistry is a huge subject. Simple organic molecules contain carbon and hydrogen only, but other organic molecules may contain carbon, hydrogen, and combinations of oxygen, nitrogen, phosphorus, and even sulfur. It's really important as you begin a study of organic chemistry to really get the hang of a couple of basic concepts. First of all, you need to be able to draw organic structural formulae. And the second thing that you need to be able to do, you really need to be confident that you can allocate the correct systematic name to organic molecules that you come across. We'll start with the simplest of all organic molecules, the hydrocarbons. We'll find out what alkanes, alkenes and alkynes are. And we'll learn how to draw structural formula for each of those types of molecule, and we'll also learn how to give them a systematic name. Well, why study organic chemistry in the first place? One very good reason is that it can become the study of life itself at the molecular level. As a young chemist with Glaxo laboratories in the early 70s, I was lucky enough to do research and development work on two fascinating molecules, cephalexin and salbutamol. Neither name tells us anything about the structure of the molecules. It's quite ironic really that a molecule I worked on when I was a young chemist helped save my life as an older chemist after I underwent heart bypass surgery. This organic molecule has everything. It's got a carbon chain, it's got rings of carbon atoms, and it's got functional groups. The functional groups are represented by the coloured atoms, and we'll learn more about functional groups after we've done hydrocarbons themselves. This molecule quite literally blows a hole in bacteria. The structure on the left-hand side attaches itself to the cell wall, and in doing so it stops the cell wall repairing itself. A great big hole appears and the insides of the bacterium spill out, and that's the end of it. It's a big molecule. How on earth are we going to begin to name it? It's actually not that difficult. Salbutamol is another molecule I work with at Glaxo. It dilates your bronchi and allows you to breathe more easily if you're suffering an asthma attack. Salbutamol is structurally similar to adrenaline, and in fact it mimics some of the properties of adrenaline when it's acting on you. Big name, but it's not complicated. Before we get started on the hydrocarbons, I want to show you one more quite complex organic molecule. And I want to show you that no matter how complex the name seems, no matter how complex the structure looks, the naming of it is based on some very simple basic principles, and that in fact there is simplicity in amongst all the complexity. Carbon is a unique element. Carbon atoms can join together to form short chains. They can join together to form long chains. The chains can bend round on themselves to form rings, and the rings can combine with each other. And it doesn't matter whether you've got chains or rings, you can have branches off of them. This is a steroid skeleton with a carbon atom at each corner. It's an iconic structure and organic chemists recognize it instantly. Okay, how do we go about naming steroid molecules? When we look at the diagram, there are 17 carbon atoms in the 4 rings. And to name a steroid, all we have to do is start with carbon 1 and say exactly what is attached to that carbon atom. And then we go through the rest of the carbon atoms all the way to number 17. stating exactly what is attached to each carbon as we go. And once we've done that, we have systematically named a really complicated molecule. The 17th carbon atom has got an OH or hydroxy group attached, and you can see this in the name. The aim of the next piece of work is to learn how to draw structural formulae for hydrocarbons and also to learn how to give them their correct systematic name. As the name implies, hydrocarbons are compounds that contain atoms of the elements carbon and hydrogen only. Hydrocarbons are either saturated or unsaturated. Saturated hydrocarbons contain only single covalent bonds between carbon atoms, but unsaturated hydrocarbons can contain either a double or triple covalent bond between carbon atoms. Alkanes are a family of hydrocarbons with single covalent bonds between adjacent carbon atoms. The structure is drawn flat on the page purely for convenience. Alkenes are another family of hydrocarbons in which there is a double covalent bond between two adjacent carbon atoms. And finally, the last family of hydrocarbons we look at, the alkynes. Alkyne molecules have got a triple covalent bond between two adjacent carbon atoms in the molecule. Okay, naming alkanes. We'll start with the straight chain ones first of all. Okay, the first thing we do is we take the word alkane and we knock the front of it off, and we replace the front of it with a prefix. And the prefix tells us how many carbon atoms there are in the chain. So for instance, methane has got one carbon atom, ethane has got two carbon atoms, propane has got three carbon atoms, and so on. Okay, we've learned the names of the straight chain alkanes. How about branches? How do we name branches off of a straight chain alkane? The molecule that we've got here has got a chain with three carbon atoms in it and a branch. The branch has got one carbon atom in it. Branches with one carbon atom, we name them methyl groups. Branches with two carbon atoms, we name them ethyl groups. So it's the same sort of terminology that we use for the straight chain alkanes. We start with simple ideas and we build on these simple ideas with more simple ideas. We've got a very straightforward way of naming straight chain alkanes. We've modified that slightly and we've got a system for naming the branches. All that we've got to do now is work out how we actually name alkanes with branches attached. The first thing we do is look for the longest connected chain of carbon atoms. In this case, it's three. This tells us what the parent alkane is. The parent alkane just means the alkane that has got branches attached to it. So in this case, the parent alkane is propane, and it's a propane molecule with a branch attached. The branch that's attached to our propane molecule has got one carbon atom. That means it's a methyl group. So it's a propane molecule with a methyl group. Actually, it's a propane molecule with a methyl group attached at carbon number 2. Okay, so how do we name this molecule? Well, it's propane with a methyl group attached. So we stop calling it propane, it's methyl propane. And we show where the methyl group is attached by putting a number in the name. The correct name for this molecule is 2-methylpropane. Note the slight complication of the hyphen in the name. Don't worry about that. We'll deal with chemical grammar and punctuation later. It's not that difficult. Here's a warning for all numpties out there. Just watch how this molecule is built up and note that each carbon atom has got 4 bonds in it. If it doesn't have 4 bonds in it, you've got it wrong. Okay, so we look for the longest connected chain of carbon atoms to get the parent alkane. And then we number the carbon atoms. Now, we're going to number the carbon atoms from the right-hand side this time. And the reason for that is if we number the carbon atoms for the right-hand side, the branch that's attached will get the lowest number. 4 carbon atoms, it's butane. A methyl group attached, it's methylbutane. Attached at carbon 2, it's 2-methylbutane. Who says chemistry is difficult? Even complete numpties can do it if you just apply yourselves a little bit. Check out the grammar and punctuation stuff here. And then we'll ask ourselves the question, well, what happens? How do we handle this if there's more than one branch attached? So onwards and upwards to the next example. Okay, we've learned how to name straight chain alkanes. We've learned how to name alkanes with a single branch. So we're taking one step at a time. Now we're going to look at how we would name an alkane with more than one branch on it. And we're going to take the molecule that we've just completed and we're going to stick another branch on it. Okay, longest connected chain of carbon atoms, 3. It's a propane molecule. It's a propane molecule with methyl groups attached, so it's methylpropane. But there's 2 of them, so it's dimethylpropane. Now the final thing we have to do is number where the methyl groups are attached. It's carbon 2, so it's 2-dimethylpropane, but wait, chemists like to be really pedantic and put a number against every single group that's attached. So it's 2,2-dimethylpropane. And okay, do this problem yourselves. Find the longest connected chain of carbon atoms, identify the parent alkane, find out what branches are attached and what carbon atoms are attached to. Then write down the systematic name for this molecule. Okay, stop the recording and get on with this problem now. Identify the longest chain, number the carbon atoms, identify the parent alkane, identify the branches and the carbon atoms are attached to, then write down the systematic name for this molecule. But would you mind awfully turning this recording off for a minute or two to work out the answer for yourselves? Start it again to see what the answer is. Alright, I want this one done fast. Get on with it. Just stop the vid for a minute and then check the answer out later. Stop the show, have a go, then jog on.